welcome back to my channel. So today we're going to be looking at how we convert equations to the slope intercept form. So what is the slope intercept form? What does that look like? So typically the equation for the slope intercept form would be y equals mx plus b. So in this case, the y is going to be the y values on our graph. The x represents the x values on our graph, but the m represents what we call the slope. So typically it's going to be the slope of the line, and then for the b, it represents what we call the y-intercept. And typically the y-intercept is a point where you cut across the y-axis. So b is going to be our y-intercept. So I'm going to go ahead and write that here. So I'm going to go ahead and just draw a simple graph, and then we're going to kind of like identify what the m would be and what the b would be, or what the slope y-intercept would be, sorry. And then we're going to get into examples of how we're actually converting equations to the form y equals mx plus b. So say for example, this was our graph. And remember that of course when you draw a graph, you have your y-axis here and you have your x-axis, which typically is that horizontal line that is a part of your graph. So here I'm going to go ahead and say this would be 2, say this is 4. Obviously we're going to start at 0, which is the origin, and then this would be again 2, that would be 4. So say we were drawing a line on our graph, and say we had the points 2, 2. So 2, 2 would be right here. Say we had the point 4, 4, 4, 4 would be right here. So if we were to connect to our points, we're going to move straight from the origin. When we come all the way here, there should be a straight line. So here, say we wanted to find out what the b or the y-intercept would be, we would look at the points again here where we cut across, or y-axis in this case if I was to extend the line. So this would be where we cut across the y-axis right in the origin. And then of course our slope, which is the m, is just a change in y over the change in x. I'm going to go ahead and put that here. Slope m equals change in y over change in x. So let me go ahead and erase this to create some more space here. Alright, so say for example we were looking at the slope of this line. Again, we're going to just find 2 points on the line. We already have 2 points here. So again, we're still looking at the change in y over the change in x. So I'm going to go ahead and connect these points here. I'm going to identify my y2, my y1, my x2, my x1. And then that will help me with converting my slope. So here, remember this is your y-axis. So y2 would be at this point. Y1 would be at this point, and of course x2 is going to be at this point, x1 would be at that point. So if we were doing change in y over change in x, we would be looking at 4 minus 2. So that would be 4 minus 2 over change in x over change in y, still 4 minus y over change in x, and that would be x2 minus x1. So what we have here would be 4 minus 2. So 4 minus 2, which would just be 4 minus 2 is 2. 4 minus 2 is 2, which is equal to 1. And that would give us the slope of the line. We're not really looking at graphing because we're going to get into that in my next video. But for this video, we're just looking at how we convert equations in this form. And typically, again, with converting equation in this form, it helps us with solving simultaneous equations, or even with graphing a line. Alright, so I'm going to go ahead and erase all of this so we can get into the real stuff. Say we had 3x plus 4y was equal to, say, 12, and we're trying to convert this equation to the form y equals mx plus b. What we're trying to do is that we're trying to put the equation in a form where every other variable or coefficient has moved to the other side of our equation. So here we have 3x plus 4y equals 12, and we're trying to solve for our y. What would be the first thing that we would want to move away from, or y variable? So because we have a 3x, which is another term in this equation, we're going to go ahead and move away this term first, and then we can move away the 4 that's attached to the y, or that's been multiplied by our y. So if you notice here, we have a 3x. In order to move this expression or this term to the other side of our equal sign, we have to do the opposite operation. What does that mean? We have a positive 3x here. In order to move it to the other side, we have to subtract 3x here. And because it is an equation, whatever we do to one side of the equal sign, we have to do it to the other side of the equal sign as well. So we're going to go ahead and minus 3x here. We also have to minus 3x here as well. So 3x minus 3x, this term goes away. We are left with 4y equals, and we have 12 minus 3x. If you notice here, 12 and 3x, these are two different expressions. The 12 will be a constant, and the 3x would be an expression with a coefficient and a variable. So it's kind of like you can't add or subtract apples from oranges. So these two terms are going to remain as is. However, we're going to write minus 3x plus 12. And the reason why we did minus 3x plus 12 instead of 12 minus 3x is because we want it in the form y equals mx plus b. So we want some coefficient or variable plus 12, which means that we want it in the form mx plus b. So that's why we write it in that form. So now we have 4y. We're trying to solve for y and not 4y. So again, we're going to do the opposite operation. So we have y multiplied by 4. The opposite of multiplication is division. So we're going to go ahead and divide this term by 4. And like I said before, whatever you do to one side of the equal sign, you have to also do it to the other side of the equal sign as well. So we're also dividing minus 3x by 4 and 12 divided by 4 as well. So 4 cancels 4, so we're left with y equals a negative 3 over 4x plus 12 divided by 4 equals 3. So our answer is now in the form y equals mx plus b, where negative 3 over 4 would be our slope and 3 would be our y-intercept. We're going to go ahead and do another example, and then we're going to go ahead and wrap things up. So I'm going to go ahead and erase this. All right, so let's say, for example, we had negative 3x plus 4y equals 18. So we have a negative 3x plus 4y equals 18. And again, we're trying to solve for our y term. So again, here we have to try to move all the numbers away from the y term, or all the expressions away from the y term. So the first thing that we're going to move is our negative 3x. And since it's a negative 3x, we're going to move it as a positive 3x to the other side. So here we have a plus 3x. We also have to add 3x to this side. Again, we're working with an equation. So whatever we do to one side, we also have to do to the other side of our equation as well. So a negative 3x plus 3x, this term cancels. So we are left with 4y equals 3x plus 18. So here we have a 4y, and again, we are trying to convert this to the form y equals mx plus b, but since we have a 4y and we just want y by itself, we're going to have to again go ahead and do the opposite operation of multiplication, which is division. So we're going to divide all these terms by 4. So here we're dividing this term by 4, dividing this term by 4, dividing this term by 4 as well. So 4 cancels itself again, so now we're left with y equals 3 over 4x plus we have 18 over 4, which can be simplified by dividing both 18 and 4 by 2. So 18 divided by 2 equals 9. 4 divided by 2 equals 2. So plus 9 over 2. And this is the form y equals mx plus b. Please stay tuned, because we're going to be exploring a lot of other interesting topics. We're going to be looking at substitution, elimination, and also the ways in which you use this same type of equations to graph a line. Thank you guys so much for watching, and please do not forget to subscribe.